awesome. Well, now we want to go into HAL, actually, which was a great transition there.
Yeah.
So now we're going to basically show you how to install HAL onto your Raspberry Pi with a Matrix Creator or Matrix Voice. We're going to go into some examples that we have on our documentation, and then we're going to code a very simple app for you. So now I guess if you could switch the screen, Samarine.
Yes, I will do that.
And basically we're going to start off already SSH, or we're going to SSH into the Raspberry Pi. If you don't know what SSH is, or if you would prefer to use a desktop, I suggest you look at our previous video where we go over how to use SSH, or just how to set up your Raspberry Pi and Matrix Creator on the desktop and with SSH.
Right.
So from there, you can continue on with here.
Yeah, so the last video, which was episode 101, setting up your Matrix device, Carlos went over how to, kind of the docs, which is you just go to Matrix, or I'll do it right now, docs.matrix.1, and that's pretty much all of our documentation. There's it's very well documented, has each layer. So there's MOS, Core, and HAL, and obviously today we're going to do HAL. So we're going to go in there and get...
And HAL is our lowest layer. It's
yes.
the closest you'll get to the board. Well, unless you want to go into the FPGA, but that's a completely different beast in itself.
Right.
And HAL, you program it all in C++, like what Sean and Connor were saying. It's very similar to Arduino, and we've abstracted things out like the IMU, the Everloop with all the LEDs, the microphones, and just all the other sensors on the device.
Exactly. So HAL, C++, like you said. Actually, I also coded in Arduino primarily before, getting introduced to the Matrix Creator, and I first started in HAL as well. It actually was an easier transition for me, since HAL is also in C++. So for installing, we're just going to do installation from package, and so let's SSH into the Pi. So the command is pretty simple. It's also you can figure out your IP address for your Pi by plugging it into a monitor, or
and you can find out more information on that on our previous live stream episode 101.
Yeah, so we know our Pi's IP, so we're just gonna go ahead and SSH. So there we are, we're inside our Pi, which is awesome. So all I have to do for here, which is super nice, is copy and paste.
Yeah. So at the top of each of the code boxes, we have a little button that will pop up, so you can very easily copy it. The first command is basically setting the keys, so what libraries to reference in order to download our libraries. And then now we're just doing apt-get, update, and upgrade so that we can download our libraries and update the Raspberry Pi. So this will take about a minute. It's not much. It's, I don't know, maybe a couple megabytes, if that, worth of files. And this has all of the base libraries needed for the Raspberry Pi to communicate with the Matrix Creator, and then for you to program it in HAL. So now it's just started the upgrade part. You'll want to press Y to continue. Yeah, and it'll just keep going with that. And then after this, we're going to do the sudo apt-get install, and that is basically going to install our libraries. Yeah, so let's give that a second there.
In the meantime, do you want to talk about any projects in HAL that we know of, or I guess the grandfather clock is one that we already talked about.
Yeah, the grandfather clock's amazing. One cool project that I actually was working on a while ago, which here I could get it. I was trying to make a drone. So this is a drone. It's controlled by a Matrix Creator on the bottom. I have a Pi camera here because I wanted to. We're based out of Miami, so I wanted to fly over some areas, maybe the beach or the water, just areas where there's not people at the moment, just to take some cool pictures and aerials for like a screensaver or something, and just to have a drone because it's super fun. So didn't get to finish it. I've tried to implement like the flight controller for the drone, which is what handles all the math to stabilize it on the FPGA, which was more difficult than I thought. But yeah, I mean, it's a really cool project, and I've heard from several people that they too want to make a drone, and they're trying to make a drone. I know there's a university in Colombia actually that was making a drone, and we have a video of that on our website. And this past weekend, actually, we went to a hackathon. It's a Major League Hacking hackathon called Shell Hacks here at Florida International University, FIU, in Miami. And at the hackathon, there were like 700 people there, all like creating various projects. We were there. We were one of the sponsors. We had a table, talking to people, showing them our robot arm demo. And then we sponsored them by giving them 10 hardware kits with the Matrix Creator, Raspberry Pi, SD card, power supply, basically everything they need so that they can just make some cool project with the Matrix Creator over the weekend. And they had 36 hours to make these projects, and we had a prize where the team who made the coolest project, each team member would receive a Matrix Creator. So we had some cool projects. One project, which unfortunately they didn't finish, but it was basically, they had a robot that was, were trying to get it controlled through the Matrix Creator. They didn't have enough time to finish, but a robot controlled through with a fish. So they bought a little like black goldfish. They had it on top of the robot, and then they had two paddles so that the goldfish, goldfish normally like to like hit the walls of whatever tank they're in. So when it would hit the forward paddle or the backward paddle, the robot would slowly move forward or slowly move backward. And then they were also using the Matrix Creator as like lights in order to train the fish, because apparently goldfish can be trained with lights. I had no idea.
I didn't really know that either.
Yeah,
but somebody was telling me that goldfish, especially the black kind that they had, are blind. So like they apparently, that's why they bump into the walls. And that's why, like, for their application where they're trying to get like it bumping into things and then using that flex sensor as the control for the motors, like that's why it like was supposed to have worked.
Interesting. Okay. But, wow.
Yeah.
Well, yeah, I mean it's just such an amazing concept. I wish that they would have finished it, but oh well.
It was a cool concept, but I definitely felt kind of sad for the fish. The fish was, I definitely felt sad for the fish.
Yeah, I mean, they were feeding the fish. Yeah, I think they kept the fish like up with them overnight, and so we didn't get much sleep over the hackathon.
Didn't get much sleep, yeah.
But it was an amazing concept. And then the team that actually won our challenge, they basically made this kiosk using the Matrix Creator, a Raspberry Pi camera. And the point of the kiosk is so that, let's say you are in trouble if, let's say in like a human trafficking type scenario or anything else. You can go up to the kiosk, speak, tell it like your name, say help or whatever, in whatever language. So English, Spanish, they had a whole set of languages set up with it. And then it will record whatever you say, translate it to English, and also take a picture of you, which they will then cross-reference with a database of pictures that they already had and with just pictures of people that have gone to it before, in order to like see if you had gone to this before and just try to get you help. So that was really amazing. They used like the creator for the lights, for the microphones, in order to get the sounds of the people's voices, and then they connected it, I think, to Google Cloud to do the speech, to Microsoft Azure to handle something with the database, for AWS to, I think they were doing the facial recognition on AWS. They used all three like major cloud platforms, and they actually got it to work within the 36 hours, which that blew my mind the most. That they
got it all together. Like the cross-platform integration was. I don't know. It blows my mind.
It was amazing.
Pretty awesome.
And I mean, they were like pretty experienced, like hackathon guys. I think they had like 15. They've gone to 15 MLH hackathons, so they for sure know what they're doing. But it was even then, like us knowing what we're doing, it's tough to do that type of project, that complex of a project in that little amount of time. So I think we should have done the apt-get before we started the video.
This is taking a little bit longer than expected.
Let's give it a little bit more. Okay. Let's give it like 2 more minutes, and if not, we have a backup device that already has it on there.
Not sure.
Okay, but that hackathon was really amazing. It was crazy. There was I've been to a couple hackathons, but 700 people in a hackathon.
Yeah, it was kind of crazy. 750, I believe.
Oh,
so even more.
Oh my god. Yeah, and we were speaking to the organizers, and they said they got like 850 applicants, and they only expected like 600 to go. Because normally with events, not everyone goes, but more people ended up going, and so they were a little overwhelmed at first. But the Shell Hacks guys, they did an amazing job with the hackathon, and it worked out so smoothly. It was really good.
Yeah.
Yeah. Great.
Right.
So right now, processing triggers for ManDB. Okay. So,
How long do you think that'll take? I don't know.
Hopefully,
but like once this
less.
happens though, like the sudo apt get install should.
Oh yeah,
take
that's
that long.
super quick.
Really quick, and then just rebooting the device.
Yeah.
So, well, I mean, I guess in the meantime, I could go back to the screen and talk about what we would do there.
Yeah, well, we could show like the. Oops.
Oops.
No, you're good.
Does that do anything?
No,
oh my
you'd
god.
be fine. You're fine.
Oh my god.
Yeah,
okay.
so I mean, so we could like open a new tab.
Yeah.
Go to docs.matrix.1, and then we could just show you some of the examples that we have in HAL already there. So one thing that we really like to do, so over the summer we updated our documentation, made it amazing. Thank you to Boris and Carlos on our team for that. They worked really hard on it, and it shows. So as developers, when we're going into something, when you're first starting out, it can be really difficult to figure out how things work and actually get things to work. So the examples page on our documentation, we set it up so that it has all of the code you need. So as long as you just by copying and pasting the code that we have on there, you'll be able to get it to work for sure. And we test these things whenever any update comes out, just to make sure that anybody starting out where like you don't really know everything that's going on, and trying to figure out all these complex things can be really difficult if it's not all there for you. And so we've just put it all there for you. Yeah.
Mm-hmm.
So the sudo apt-get upgrade and update finished, and Semrine just put in the command to download our libraries.
Mm-hmm.
So
hopefully that won't
finish
too
up.
long. But today I think So today what we're going to do is kind of show you how easy it is to kind of go through the examples that are already there, and then go through like a quick sort of custom program, very simple, to understand like how much you can copy paste from what already exists, and kind of like all you have to do is just put in your logic behind whatever kind of program you want to do. So yeah, so this is the IMU example, and I want to do this specifically because the program I want to do later is going to be like very simple, like when the creator is at a certain orientation, have the lights be green, at a different orientation have it be red, at a different orientation have it be blue, and then have it be nothing for another orientation.
Yeah. In case you don't know, IMU stands for Inertial Measurement Unit, and that is basically the component on the matrix creator which includes the accelerometer, the gyroscope, and the magnetometer. It's one component that has all three, and from that you can get the XYZ values for the acceleration, for the gyroscope, for the magnetometer, and then we have some little abstraction there to combine those sensors so that you can get yaw, pitch, and roll. And that's actually what I was using on the drone. So because I was using the matrix creator as the gyroscope, as the IMU for the drone, so I was just getting the yaw, pitch, roll values, and that's how I was trying to stabilize it.
Yeah, and that's really fun because you can use yaw, pitch, and roll for pretty much like, like it gives you orientation kind of in 3D space. What is going on? Is that
yeah, it's just down.
Okay. It's just like I just haven't seen the big steps before.
Yeah, it's just the pi serial.
Okay,
yeah.
Cool. Well, okay. Sorry about that. But sudo reboot, which I don't have to copy, but copy it. Okay.
Okay, and so now we'll wait a minute for the pi to reboot.
And then we'll SSH back into it.
Yep.
And then we can show you the simple IMU example, and then I can show you, it won't take too long to basically copy paste all the cool parts and you know, then just your logic, and you can do whatever you want.
Yeah.
So,
And we'll go through like explaining everything we're copying and pasting, the includes, the various libraries,
Yeah.
and then like our logic of the code. And you'll see it's really simple. That was our goal, and we hope you feel the same way. And if you don't, please go on our community, community@matrix.one. You can ask us any questions there, and yeah, we'll answer them, help you, and from there our engineers will go improving our stuff so that it's just better for everybody. Okay, so now we're back into the pie. Yeah, and go ahead.
So
well, let's start off with like an Everloop example, just so that we see that everything's working. So you can go in, it's already downloaded. Oh no, my bad, haha.
Yeah.
Okay, so what we can do then is download,
Okay.
make the file and then copy and paste the example.
So this is like when you first like download the package, and you know, the next, like the link at the bottom of the page basically takes you to how you kind of start off, and then you just basically tells you to make a program directory. So I'm just gonna copy paste because it's easier.
Yeah. So CD puts you into the home directory. MKDR is make directory, like a folder called Matrix HAL project, and then CD is basically like change directory, going into that folder essentially. Yeah.
So then to make an app, I think I can just do touch app.cpp, and then I can so then I should be able to nano sudo nano.
And nano is a text editor.
And I should be able to just kind of copy paste this code. So this code just turns the Everloop on for 10 seconds, and I won't go through the code line by line right now, because I will go through the code line by line when we write our own one.
Yeah, but you can go through this yourself. All the lines are commented. That way you know exactly what's happening.
Very, very well commented. It's just super nice. And alright, I'm gonna save it, which I think
Control
is
X.
Control Command.
No, it's Control.
Control?
Yeah.
Okay. Control X. Yes.
Enter.
Enter.
Cool.
Okay.
And then now we have to compile it.
Compile it, which it also says here, which is super nice. Which I can copy and paste.
Enter. Oh, okay. Give it a second. Okay. Cool.
Yeah, so there we go. Now you have your app. And
now we can scroll down on the docs so that you can see the command.
Right.
And it says right there, CD into the project, just as a precaution in case you weren't in it already.
Yeah.
And then
just run it. So I don't know if you guys can see. You should be able to see.
Yep.
There we go.
Yeah, and that's easy. And we
just for 10 seconds.
And we copied and pasted all of that code. None of that we wrote ourselves now. So it shows you, like, just by copying and pasting it, reading through it, you can figure out what's happening and then start creating whatever you want.
Yeah, so after this, you could definitely go into the references and check out like whatever you want. So we're in like the IMU example. I could do the example, or I guess I could just go straight into what I wanted to do.
Go straight into it.
Let me just go straight into it, because you'll be able to see everything. You'll be able to see what's going on anyway. So I'm just gonna like make like another file. I'll call it like test.cpp.
And just for simplicity, because you saw nano, all the text is green, which is fine if you want to do that through SSH. We have something set up with a program called CyberDoc, and basically what we have set up is SFTP, so SSH FTP file transfer protocol. So we'll be able to directly edit that file from our computer instead of doing it through the SSH.
Yeah, so the way like CyberDuck usually works is you hit open connection, and then over here if you do SFTP, so SSH file transfer protocol, and then put your IP address right there, and then the username, which is usually Pi, and then the password, which is usually Raspberry. It's already here because we've connected before. And then once you connect, it's really nice because kind of the directory shows up here and I can see all my files. And the reason like we like this is because we can kind of go into Visual Studio Code, which is our preferred text editor, but it could be whatever for you.
Yeah, it could be Atom, it could be Sublime, Notepad++, anything you want. We just like VS Code. It's nice.
So for this program, which we just want to read the IMU data, so get some there are like, you know, role, pitch, yaw, and like other fields as well, but we want for this particular one I'm going to use role, but I'm getting ahead of myself. The main thing is you want to, so you, when you start off, you want to make sure you have the right libraries and like include statements. So I'm just going to copy paste like the, you know, IMU sensor library, the IMU data library, and the bus library, and I'll talk about why you need each of them as we keep going. So over here, like, you have the IMU data object that you need to create. So the way this works is, so I'm gonna go into main, and then have my return 0 at the end. And so yeah, I would make an IMU data object, and what that basically does is it creates the object that is holding all the fields that like of the data that you need. So it'll have heading, it'll have pitch, roll, it'll have x acceleration, y acceleration, z acceleration, like, and it has a bunch of, you know, other data fields, and you can pick whichever one you want. So so I did, actually, before I do that, I would want to open the bus. So okay, so it says for starting off, I would need to like make a bus to open up the lines of communication, and that is as simple as going into the matrix HAL library and
Okay, we're unmuted.
we're back.
Sorry about that.
Sorry, yeah. So...
Okay, so let's double back on what you just said, I guess, from going now to the example on the IMU.
Okay. So going back to example on the IMU, so I can copy paste more from here because it's literally like the whole example of how to read data from the IMU. So here I already have the system calls, well, actually I don't have the system calls. I'm actually going to copy paste everything because if you want to print something, or, you know, like basically like you need the system calls for like cout and stuff like that, and then
just standard things you need in the
standard things you need for like just general C++ things, and then these are for the objects that you'll make. And I'm going to delete this stuff because I have more to copy paste now. So initial setup, like it says, it's just setting up the bus. So you open lines of communication, and I'm going to do that so I don't forget. And then you initialize and exit the program if an error occurs. That's basically error catching, right? So if it doesn't work out, you'll know because it'll exit the program. And then for the setup, I'm gonna copy most of this and then delete some of it because I don't need all of it. So, or you know what, I'm just going to copy this part. So what it's doing here is, so it is creating an IMU data object which holds the IMU data, so the roll, pitch, heading, x acceleration, y acceleration, which I said before as well, and then the IMU sensor object, so it's creating the sensor object basically. So when we would read the data from the sensor object, and it will be stored in the fields of the IMU data object, from what I understand. Yeah. So, and then the IMU sensor.setup and bus basically sets that sensor up to communicate on the bus that we just opened up. And so what we want to do in this program is use roll so that we can basically like the role is kind of, it gives you the, so if you move the, I don't know if you can see the creator. Okay, so if you move the creator like this, that's roll. If you move it like this, it's pitch, and then if you move it like this, it's yaw. So I just want to say that, like, okay, depending on what position it's in, I want it to be different IMU colors or different LED colors, and the way the like roll works for this particular IMU is the range is between negative 180 degrees to positive 180 degrees. And I know this because from this example, it actually prints out the roll. I'm trying to kind of to save time. I didn't do the IMU example, but if you literally just like downloaded the example and ran it, it would print to the screen the different values for heading, pitch, and roll, and you would know, you could play around with it and you would know what the ranges are and everything.
Yeah, and 0 would just be flat.
Yeah. So for here, I'm going to do a while true as well because I want it to continuously run, and then basically have like float, and all I want is roll. So I'm going to say roll equals, well, I have to read the data before this, but I'm going to write this anyway because I'm already here. So yeah, so before this, you would want to set up the sensor so that it can read. So basically this line right here. I'm going to copy that. Let's see. So this is so basically when you're doing IMU sensor.read, it's basically exactly what it says. It reads from the IMU sensor, stores it in the IMU data object fields, and right here we have we're just using roll because that's pretty much all we need in this case. So I think that's all I need from the IMU. I will put a delay in here, or like a, not delay, but yeah, kind of a delay. It's like the sleep, because you need that for, I'm going to put 20,000, that's microseconds. And that basically would mean it would update every 20,000 microseconds.
Yeah, or 20 milliseconds or 0.02 seconds.
Yes. So I will now go to the Everloop reference so that we can include the Everloop stuff. And so as you can see, a lot of this is copy pasting. Actually, pretty much all of this so far has been copy pasting, and this kind of goes to show how easy it is to work with HAL. So this is already in here, so I'll delete that part. So here we're including the libraries for the Everloop, which is just everloop.h and everloopimage.h. And here we have this part, which I will explain as I do. So here, I like it to look kind of nice. But all right, so when you do int LED count equals bus.matrix LEDs, actually before this I will have to set up, well, actually the bus is already set up, so never mind. But basically what's happening here is, like it says, like the bus.matrix LEDs holds the number of LEDs on the device, because we have the voice, which has 18 LEDs, I think. 18.
Yes, the voice has 18.
And
yes.
the creator, which has 35 LEDs. I sometimes forget these numbers.
And here, let's do Command plus so that the code is larger.
Oh, okay. Yeah, good idea. Sorry about that.
Yep. All right. And then press X on the bottom.
Yeah. Sorry.
Cool.
Okay, cool. Thank you for reminding me about that.
Yeah, no problem.
All right, so actually I'll go into the code example here as well, because it's more to copy paste. So I'm actually going to go into Everloop green, because the first color I'll set it to is green. So, you know, the libraries, which we've already added, and the bus, which is already initialized because we did that for the IMU. And then we have the LED count, bus.matrix LEDs, so that's just getting the number of LEDs. And then, so what this does, create Everloop object with size LED count, is kind of like make like a virtual image of the Everloop, so that then you can write that into your, like, you know, Everloop hardware. So basically, after that, you make an Everloop object. So that's basically the like the actual LEDs that are on your device. I'll copy the comment as well so that it's not confusing. All right. Whew. Okay, so the Everloop object, so basically whatever you kind of like set the like LEDs in the image to be, you can then write the image to the Everloop object, which would just make the LEDs on the hardware light up however you want. So then Everloop.setup and bus, so that the Everloop can also now send information through the bus. So for kind of changing the LED colors, the code is really simple. It's this right here. So I'm gonna copy that. And I'll explain in a second what that does, and I'll copy it right here. I'll put it in an if statement actually. So before I copy paste that in, I'll make the if statement really simple. If roll is greater than 0 and it's less than, say, like 90, I want it to be, you know, a certain like color. And so, ooh, Command Z. Trying to tab here. Okay. So if roll is between 0 and 90 degrees, I want the LEDs to turn green. So what it's doing here is, for each LED in the Everloop image, which is kind of the virtual Everloop, we're setting the LED value. So here we're saying, okay, red is 0, so there's no red, there's no blue, there's no white, and we're setting green to 100, so it's only going to be green. Pretty straightforward. And then the reason you do the for loop is because you have to set it for each and every LED. And then at the end, after the for loop, like, so after you set each and every LED, you update like the Everloop with the Everloop image. So what that does is that, like, it'll turn all of the LEDs on at once instead of like sequentially, which it would have done probably if you had, like, you know, like had the image for one LED, written it to the Everloop and stuff like that. So this is super simple. I could, honestly, for the sake of time, I'll probably just have it do green and red. And like, well, because I mean like it's pretty straightforward. You can already kind of see what is happening. So I'm just gonna have an else, and I'm gonna copy this again, put it in here, and make it go red. So like green would become 0, and then red would become like 100 or some other number between 0 and 255.
And as a reminder, the Matrix Creator, Matrix Voice, all their LEDs are red, green, blue, and white. The white one isn't the combination of the red, green, and blue. It's actually a separate LED within the module for the LEDs. So you can do like hues and like pastels and different things like that.
So I think that's about it. So the sleep will make it so that the LEDs don't kind of freak out and have time to change color. And I think that's all there is to it. I should be able to compile and it should hopefully work. So I'm going to save this, Command S, which should technically, whoa, that shouldn't happen. It should just say
okay, yeah, beyond.
It should just,
you're
I
on.
was beyond, okay. Beyond CyberDuck. But anyway, so if you're in CyberDuck, what's kind of nice is like it temporarily downloads it, it changes it, and then when you save it, it uploads it back into the Pi. So that should be saved in the Pi right now. So I'm going to go into the terminal and compile the program, which the command is right here. I'm not going to copy paste it just because, actually I'll copy paste it and then it'll freak out and then I can change. Alright. And I'll change your CPP file to test.cpp and your output file to test. So test. And, well, this one is a CPP file. Yeah. And test.cpp. Alright. Hopefully I didn't forget like a semicolon or like parentheses, but
we'll find out.
Always happens to me. Yes! Okay, so I really hope it works, and then we'll be out of your way. Okay, so it's a little dodgy, but just because like I didn't have any like kind of deadband, like it's literally like changing like really
the second
quickly.
It changes the angle,
it changes the angle,
so it's very sensitive.
You see how it's green right now? Should I go to the full screen?
Yeah.
I'll go back to the full screen. Give me a second. Still getting a little bit used to these controls. We'll get rid of that and waha. Awesome. So it's green and then tilt red. Woohoo! Green, tilt red. So basically, like, I know it sounds super, like, it looks super, like, simple and, like, you know, you're like, oh, what do I do with that? But the thing about it is, like, using this, you could use it as an indicator for, you know, like kind of information when you're coding, but also like this kind of shows you how you can use like the IMU, which is super powerful. Like you use like, I mean, if you think of like drones, planes, like things like that, like they'll use multiple IMUs and like combine that feedback for control. So there's a lot you can do with it. Like
and it just shows you just by following our examples, by following the reference code, it's really simple to, you know, use our device, and then all you have to worry about is what you want to do with it. I mean, we just combined two different components, the Everloop and the IMU, and it worked first try, which that in itself is amazing. So yeah, I mean, it's really simple.
So I will switch back to this camera so that we can look in front. And all right, so that was our getting started with HAL tutorial, and I hope, you know, you all can see how like easy it is to program and like how much of it you can copy paste. Like, yeah, you want to understand what's going on for sure so that you don't like mess up, but like at the end of the day, it's just logic for whatever you want to do that like you really have to think about. And
yeah, it was just one if statement and an else on that. That was super simple. You can't get simpler, really.
Exactly. So right now we actually could show us the loop again. Is that recent?
No, that was a while ago.
Okay, never mind.
But we can open it up to Q&A. So in the comments section, feel free to type any questions that you may have. Remember, there's like a 6-second delay. So in that 6 seconds, we'll just be talking about something. There were a couple of announcements that we wanted to do.
We can make them while we wait for questions.
Yeah, sure. So you want to talk about the project we're working on GitHub, or which one? Actually, here, the coolest one. So earlier today, was a new issue of the Hackspace magazine came out. If you don't know, Hackspace magazine, it's a magazine run by the Raspberry Pi Foundation, the people who make the Raspberry Pi. And it's every month they come out with a new magazine of various hardware things and using the Pi, not using the Pi, just cool things and different projects that people have made. So this month's issue features Alex Glow from Hackster.io. She's like their chief hacker. She's amazing. And if we switch over to the screen, you'll see that we are actually on the cover of it.
That's amazing.
Yeah. So here, if you could zoom in a little bit on it.
Come in.
And if you want to go see it for yourself, you can go to hackspace.raspberrypi.org. And the magazine directly would be /issues/11. And there you can see the Matrix creators on there, and in the magazine, Alex is basically talking about like the best maker hardware, whether it's FPGAs or sensor boards or boards for AI, microcontrollers, things for connecting to 3G or LTE, all of that. So it's a really great magazine and a really great article from Alex, and we're super excited to see that we were featured on there as well.
Yeah, very, very excited. And like if you go in to you can actually download it for free.
Yeah, you can download it for free, or you can purchase the physical magazine from their website.
Yeah, and it is a very like good looking like magazine. It looks so pretty, and it's like actually fun to read. And it's like, yeah, you should definitely check it out if you want to like be doing all the hot stuff.
Yeah, we're super excited to have seen that. So then the other announcement is from October 16th to the 18th? Yeah, October 16th to the 18th is ARM TechCon in San Jose at the San Jose Convention Center in California. So we're going to be there. In case you didn't know, ARM has this amazing innovators program, and back in the beginning of the year, we were selected as one of their innovators. So we're going to be at ARM TechCon with a booth within the innovator area, showing off our robot arm. So Samarine and I will be there. You can go talk to us. It's open to the public.
Yeah.
Actually, the entrance is free, like it says there on the website. So you can go to armtechcon.com and go register. Yeah. So that's going to be really cool. And that's, again, October 16th and the 18th. Yeah, and Hackster.io is also going to be there, and also, I believe, Alex as well. So it's going to be really fun. Yeah, and then the other announcement is later next week. We will be either early next week or in the middle of the next week. We'll be posting this cool guide on Hackster.
Yes.
And it's well, you want to say what it is?
The cool guide on Hackster?
Yeah, the MATLAB one.
Oh, okay. Yeah, we're back on this camera.
Oh, okay.
So, cool guide on Hackster. So what we're thinking of doing is, we know a lot of people like to process mic data and stuff on MATLAB.
Yeah, especially like researchers, students, so on.
Yeah, for researchers and students especially. So there's actually this library in MATLAB which you can use to kind of stream data from the Raspberry Pi, sensor data. So we're looking into how we could stream data into MATLAB, either through that library or some other sort of way that maybe stream from your Pi or from Pi and Creator straight to your PC and then pipe it into any program, and maybe use MATLAB as an example. But we're working on that, and hopefully that'll be out soon.
Yeah. And then that's just for, we heard a lot because there's a lot of researchers and students and professors who use our devices, and, they just wanted a simple way to stream the data to MATLAB on their computer. So, yeah, we're going to make that. And if you have any project ideas, please go on our community.matrix.one. Post whatever ideas you want. Maybe we will make it, or someone on our community will make it. And yeah.
Yes, and last live stream we announced we were going to open up the projects category on our community, and we did that a couple of days ago. So if you have fun projects, even if it was just a project that you did I don't know, for your home or something, post it on our projects category. It's just a fun way to share ideas and cool things you've done and get some feedback or discussion.
Yeah, and all future projects that we'll be making, we'll be posting there, and we'll on it. We really love using Hackster.io. They provide a really nice way to post projects. So it'll basically be linking to Hackster there. And if you have any projects, feel free to post them on Hackster. It's a really amazing platform.
All right. Well,
okay. So let's see. Do we have any questions?
Looks like no.
Doesn't look like it. Okay, so I mean, if you have any questions, I guess we'll wait a minute, and if not, we'll end out the stream.
Yeah.
So
I think since we had the questions open for a while and nobody's asked, I think that means this must have been an amazing tutorial.
Yeah.
So no questions means no problems, right?
Yeah.
So, well, if you do have questions later, you can always comment and always ask us. Oh, looks like we have one.
Oh, okay. Yeah. So the question is, regarding the Matrix Creator sensors, can I use the IMU with all the other sensors? Is there any sensor I cannot use with the others at the same time? So the answer to that is, yeah, you can use them all at the same time. We basically, the way that we set up the Matrix Creator is all the sensor data goes through the ARM microcontroller on the Matrix Creator and then gets piped to the Raspberry Pi from there. So it's just really quick, really real time, and yeah, there's no limitation there. Yeah.
Awesome. So I think with that, we'll... Oh, wait.
Oh, another one. They're coming. Do you have any 3D model I can use for designing a case for it? Yes. So if you go on our GitHub, github.com/matrix-io, and if you search for, I believe, Matrix Creator, you should be able to find the .step files for the Matrix Creator. If they're not on there, I'll go check after the stream, make sure they're there. But you can also always search on our community. There's a search bar at the top right, and I'm pretty sure a couple people have asked for that before already.
Yeah.
So it'll be there if anything.
Awesome.
Yeah. So
all right, great questions, and I guess we can wrap it up here.
Yeah.
So thank you for being here, everyone,
thank you.
and I'm Sumrine again, and this is Alfred, and you'll be seeing us in 2 weeks.
Yeah, October 4th is our next live stream, so please tune in then, and yeah, thank you again.
Yeah,
have a great night.
Have a great night, everybody.
Bye.